Hi everyone, in today's video we're going to talk about inverse trig graphs. So on your paper you're going to see the graph of sine. I graphed it from negative 2 pi to 2 pi and I put the chart of the values here. So for example, at negative 2 pi on the angle at theta, sine or the value of the function is at 0. And another example, negative pi over 2. So at negative pi over 2, the graph is down here at negative 1. So this table makes up all the points for this sine graph. And if you look down here, you will see an empty graph. And in this empty graph, we're going to graph the inverse sine. Now remember, the notation for inverse is sine negative 1, or sometimes it's referred to as arc sine. So we have to recall the definition of an inverse. We remember that inverse means to switch x and y values. So if you look at this chart right here, all I've done has switched all of the x values with all of the y values. So if you see here, these x values on this whole column are all here, and these y values now are all here. So what I would like us to do is graph this. So we know that if this is our x values and these are our y values, it's our x values that only have 0, 1, and negative 1. So on our x, we're going to just, make it a little bit wider. So instead of putting 1 right here at the spot where it should be, I'm just going to extend it. So maybe I'll put negative 1 here. So how many spaces did I go over? 1, 2, 3, 4, 5. So I'll do the same thing over here. 1, 2, 3, 4, 5, and I'll put another mark. And now it's our y-axis here that will be all of our values here. So we need from 0, 1, 2, 3, 4 tick marks, so 4 going up and 4 down. I'm going to probably count 2 spaces, so I'll go 1, 2, 3, and 4. And I'll do the same thing here. 1, 2, 3, and 4. I'm just spacing it out a little bit. So here will be positive pi over 2, positive pi, 3 pi over 2, and 2 pi. And then we'll do the same thing in the negative direction. So negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Now, once you have all of that done, we can start graphing. So if you need to pause the video, now is a good time to do so. So we're going to plot 0, negative 2 pi. So when x is 0, y is negative 2 pi. So down here, sorry. And now we have the next one, 1 and negative 3 pi over 2. So when x is 1, y is negative 3 pi over 2. Next, 0 and negative pi. So when x is 0, y is negative pi. Next, negative 1 to negative pi over 2. Next, 0, 0. Then we have 1 and pi over 2. 0 and pi. Negative 1 and 3 pi over 2. So that's going to be here. And then 0 and 2 pi, which will be here. So what we're going to do is actually connect. So remember to connect it curvy. And this would be your inverse sine. So if you take a look at your inverse sine function, you'll notice that it's not a function because it actually fails the vertical line test. Any vertical line that you draw could hit in more than one spot. Like this vertical line here hits 1, 2, 3, 4 times, and so does this, right? So it wouldn't pass. So sometimes you will see a question and it'll ask you this: what do we have to restrict the domain of sine of theta so that its inverse is also a function? And the answer to that is really we have to look at sine. And what you want to do is look for a piece of this graph that's hovering around the 0 marker such that it passes both the vertical line test and the horizontal line test. So if it passes the horizontal, that will also mean that the inverse will be a function. So if you take a look here, it's really just from here to here is this section of the graph that passes both the vertical, hits once, and the horizontal line test, hits once. It would be if I were to continue the graph here, it would fail the horizontal. Or if I continued the graph here, it would fail the horizontal. So again, you're looking for a section in the graph that's hovering around the 0 marker such that it passes both the vertical and the horizontal line test. So the answer is we're going to restrict the domain of sine from negative pi over 2 to pi over 2. So we could say negative pi over 2 is less than or equal to x, less than or equal to pi over 2. That's how we would write all values between negative pi over 2 and pi over 2. You could write it either of these two ways. This is your interval notation, and this is your set builder notation. And unfortunately, there's no easy way around this. This is kind of something that just needs to be memorized, or if you have a really good grasp of what sine looks like, you could always graph sine and then look for where it passes the horizontal and vertical such that it's hovering around 0. All right, let's take a look at the next graph. We're going to graph cos, or we have cos rather, we're going to graph its inverse. So I did the same exact thing as I did with sine. I have here the graph of cos, and I have all of the points that make up cos. So now what I did to find the inverse cos, or cos negative 1, also referred to as arc cos, I switched all of the x values went here, and all of the y values go here. So what we're going to do now is we're going to graph cos inverse. So again, here are my x values, and here are my y values. So again, x is from 1 to 0 to negative 1. So I'm going to do the same thing that I did before. I'm going to go over 5 spaces and put negative 1, and then 5 spaces and put 1. And I'm going to set up my y-axis the same way. I'm going to count by 2s. If you want to count by 3s, you can. I think there might be enough space, but what we're really trying to do here is just spread out the graph a little bit. So we're going to do, again, pi over 2, pi, 3 pi over 2, and 2 pi. And same thing down here, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So now's a good time to pause the video and make sure you have your graph set up correctly, and then hit resume when you're ready for the graph. So we're going to plot the point 1, negative 2 pi. So we're going to go over 1 and down 2 pi. Then we're going to do 0, negative 3 pi over 2. Then we're going to go down left negative 1, down pi, negative pi. And then 0, negative pi over 2. And then 1, 0. 0 pi over 2, negative 1 pi, 0, 3 pi over 2, and it looks like I forgot 2 pi, so that would just be 1 and then 2 pi, so feel free to add that. So 1 and 2 pi. And then make sure you connect your cosine graph. Try to make it as curvy as possible, and this is your inverse cos. Again, they'll ask you the same question. What do we have to restrict the domain of cosine so that its inverse is a function? So let's take a look at our cosine graph. And we want to try to find a section of cosine that passes both the horizontal and the vertical line test, hovering around 0. So I think either here or here would work. So I'm going to go to the positive side. So from here to here is where the section of cosine passes both the vertical and the horizontal. So the answer to the question is we will restrict the function cosine from 0 to pi such that its inverse will be a function. Because like I said, it passes both the vertical and horizontal line test there. So we will say between 0 and pi, or we could write it like this, between 0 and pi. All right, let's take a look at the next page. All right, so the next graph is tangent and inverse tan. What I'd actually like for you guys to do is try to see if you can do this one on your own, and this is where we're going to pick up tomorrow. I strongly suggest you do this with a pencil just in case you make a mistake and we need to fix it. But let's just recap what we're doing. So remember, I took this table and I switched the x and the y values. So here's my new x, here is my new y. The only thing I realized here is that I forgot to bring down 0 and pi, so make sure you add that. And anytime you see an undefined value, remember that that's where we need to put an asymptote. So I'm going to put ASY for asymptote. Your asymptotes this time, instead of being vertical, are going to be in a horizontal form. So you're going to have an asymptote at negative pi over 2 here, and an asymptote at positive pi over 2, and they'll be horizontal. So set it up the same way. Go over about 5 values, put negative 1. Go over 5 values, put positive 1. And then same thing if you want, go up by 2's, and then go down by 2's, and label your values there, and graph it out and take a look and see what it gets you. And feel free to try to see if you can answer the question down here of what we need to restrict the domain to be. And that's where we'll start class tomorrow. All right, have a great night.